A boy is moving on the road and bouncing the ball on the ground. What happens when he bounces the ball on the speed breaker? Does the angle of ball change on the speed breaker or ramp? Well, the law of reflection states that the angle of reflection equals to the angle of incidence. Theta I equals theta r. Theta I means angle of incidence and theta r means angle of reflection. Suppose he throws the ball at an angle of 90 degrees. Let's see what happens then. Harry bounced the ball at an angle of 90 degrees on a curved surface. He bounced the ball directly perpendicular to the ground. So angle of incidence is 90. So due to the law of angle of reflection, theta I equals 90 minus 87.5 equals 2.5 degrees. So theta I equals 2.5 degrees. So the reflection angle is also 2.5 degrees. Angle of incidence and reflection equals theta I plus theta r, where theta I is 2.5 plus theta r is 2.5. So the total angle of incidence and reflection is 5 degrees. On the next step, he bounced a ball on the speed breaker, which is at an angle of 70 degrees to the ground. So the angle from what he throws the ball is 70 degrees. So theta I equals 90 minus 70 equals 20. In this case, the angle of reflection is 20 degrees. Angle made by the incident and reflected ball is theta I plus theta r, where theta I is 20 plus theta r equals 20. So total is 40 degrees. Third bounce is on the top of the speed breaker, which is on a flat surface. So the reflection angle is 0 again. The fourth bounce is again on the slope of the speed breaker, but this time the angle of speed breaker with the ground is 30 degrees. So you can say from the ground its angle is 60 degrees. So the angle of incidence equals theta I equals 90 minus 60. So the angle is 30 degrees because theta I equals theta r. Angle made by the incident and reflected ball is theta I plus theta r, where theta I equals 30 plus theta r equals 30. So total angle is 60 degrees. The fifth bounce make an angle of total 55 degrees. So we can say that the incidence and reflection angle equals theta I equals 90 minus 55, which is total 35 degrees. So angle of incidence is 35 degrees and angle of reflection is also 35 degrees. Theta I plus theta r, where theta I is 35 degrees plus theta r equals 35 degrees. So total is 70 degrees. What if there is a ramp instead of a speed breaker, which is at an angle of 20 degrees? A bouncing ball obeys the laws of reflection, which states that the ball leaves the surface at the same angle it approached the surface. The ball's next bounce is 3 meters to the right of the first bounce. What is the ball's rebound speed on its first bounce? The horizontal velocity of the ball along the ramp is v cos 70 degrees. The vertical velocity of the ball is v sin 70 degree. The horizontal component of the gravity equals g sin 20 degree equals g cos 70 degree. The vertical component of the gravity equals g cos 20 degree equals g sin 70 degree. Let the distance between both bounds is x. Then x equals 3 over cos 20. For more interesting videos, please subscribe to our channel.